Before we really get into the meaty section of cellular respiration, which involves the creation of ATP molecules, which, as we know, are charged with energy, we need to understand something fundamental here. And what we need to understand here is that electrons will be passed from one molecule to the other. And this transfer of electrons, as they emerge from fuel that we eat, for example, glucose, the transfer of these electrons will eventually be harnessed and stored in adenosine triphosphate, or ATP. Now, before we get there, I think I need to explain something here, and this is called oxidation reduction reactions, also known as redox reactions. So let's just imagine here, in order to explain this fundamental principle, let's just imagine that I have two molecules here, and I'm not explaining what kind of molecules they are for now. Let's just call this atom or molecule X, and then let's say this one is Y. And let's just imagine that we place those two molecules in a beaker, and we will have those two molecules reacting with one another. So after the reaction is done, and in this case here it is a transfer, the reaction is a transfer of electrons. Let's say that the X molecule here has an electron right here, and that electron will be transferred to Y. So after those two molecules react, after a certain amount of time, and that time is usually very short, then we will see that the electron has now gone from X to Y. So as you see here, Y now has the electron. Because these are called oxidation reduction reactions, we have to look at the terminology here and understand what oxidation is and what reduction is. And you'll see that it is a little bit confusing until you get used to that. So when we look at a reaction of oxidation, so let's write this, we have oxidation, and then the other counterpart of this reaction is a reduction, right? So we know here that reduction and oxidation are two counterparts of a chemical reaction, or in this case, a redox reaction. So the oxidation is the loss of electrons, and you guessed it, if we look at oxidation as a loss of electrons, well, we now know, we can deduct that the reduction is actually a gain of electrons. And now you might think, well, just wait a minute here, since when is a reduction of something a gain in something else? How is that possible that we reduce and we gain at the same time? Well, here's what you need to understand here, is that an atom that is neutral, so the charge, the charge is 0, and as this atom, so let's say atom Y in this case here, let's say that atom Y started as a charge of 0, right? So that is the start, the start point. And as it accepts electrons, so let's say it accepts electron, it now becomes -1, right? Electrons are negative, one electron is now transferred, so we have -1. As we accept another electron, it's possible to accept more than one electron, then we would go to a charge of -2, and then we could even go to a charge of -3, -4, etc. So you see, as we accept electrons, as we gain electrons, we get reduced more and more and more. So that's why we say that reduction is actually a gain of electron. And the counterpart of that, of course, is oxidation. It is the loss of electrons. So if you go down this way, this is a gain of electron, this is a reduction, but you can imagine that another molecule, and let's say in this case molecule X, since it's losing electrons, it goes from a charge of minus charge and it goes up to 0. In that case here, so since this is a reduction, on that side here we have the oxidation, right? We're losing the charges as we are losing the electrons. So that's why in that case the oxidation is a loss of electrons.